We have a video here on volume of a cylinder, and we'll see how that links to the previous work we've done on volume of a prism. So we have here, just as a starting point, we've got the volume of any right prism, and that is, as we know, we've seen that plenty of times in the past, is area times height, or the cross-sectional area times the height along the main axis. H is the distance along the main axis. So with a cylinder, it's a little bit like a prism that has a circular cross-section. So there's an example there, and cross-sectional area is that circular shape. Doesn't look perfectly circular on the sketch because it's on an angle, but anywhere, if you slice it along its main axis, each of those visible surfaces would be a circle. Okay, so we've seen that idea in the past with prisms, and it's the same with a cylinder. A cylinder is a bit like a circular prism. Perhaps that's what it would be called if it had a different name. So it's a circular prism with a circular cross-section. We know that the area of a circle is, from our previous work, is pi r squared. So instead of writing a, we can write pi times r squared. And then we still have the h there, so we times it by the h. So on the diagram, we would have the radius, which is from the middle out to this side. Alright, a big version of that would be something like this. It's the radius. We had a close-up on that. And the height, doesn't matter whether it's leaning or sitting on its base or sitting on its side, the height is that distance there. So we need those bits of information in order to task on this. So important point to note firstly is the formula and where it comes from. Volume of a cylinder is pi times r squared times h. So let's look at this truck here. It's a semi-trailer with a big tank on the back, and let's use that as an example. We firstly have to make some assumptions that it's a perfect cylinder. This one, if you have a really close look, if you can see closely there, it's not quite a perfect cylinder because that is a bit of a curvy shape on the back, and a cylinder has a flat base circle there, not some sort of hemisphere or dome. So we're going to pretend that that actually is a pure cylinder, even though this one seems to be not. And let's say we know that the radius is 3.8 meters of this cylindrical tank. So it's 3.8 meters. Let's also say that we know the length of the cylinder on the trailer, and that's 19 meters. If that's given. So let's have a look at what we've got here. So if we start this example down here, V equals A times H, or in other words, pi r squared times H, because we're assuming this is a perfect cylinder. Let's identify pi is a constant, it's a number, so we've got that. R. Do we have R? Yes, we do. So R is 3.8. Write down the given information, 3.8 meters. H, yes, H is 19. The height of that cylinder along its main axis. We've got 19 meters. We've got enough information now to substitute into the rule. You should set your work out fully like this every time. If you're not doing that, you're not doing it properly, and you'll be asked to do the work again. So we have substituting in R for 3.8, and that's squared, and times 19. Now we compute that, so pi times 3.8, and that's squared, times 19. I get 861.93. 861.93. 861.93 cubic meters. If the question asked you for, that's the volume, if the question asked you for the capacity, that's the amount of fluid it could possibly store, we have a conversion which you should remember from the previous work. 1 cubic meter equals 1 kiloliter. So that would be 861.93 kiloliters, which is 861,930 liters. It's quite a lot, but it is a truck, isn't it? So you would expect a lot. So what with a different cylinder, if we're given, instead of the radius, if we're given the diameter, which is the distance right across through the center of the circle, and let's say the diameter given on a cylinder is 24 centimeters. How do we do that? Because the formula V equals pi r squared times h has an r in it, and that doesn't have an r, that has a d. First thing we need to do then is to, before we use the formula, is to convert. Now if we find half of that diameter, we have the radius, so that's a simple matter in this one. The radius would be 12 centimeters. Now we're ready, once we know what the distance along here is, in other words the height. Okay, let's say the height is 100 centimeters. We have enough now. H is 100. Let's substitute it into the formula and see how we go. So we have pi times 12 squared times 100. Let's calculate that. So pi times 12 squared, which is 144, times 100, 45,239 to the nearest whole number, 45,239. And of course we have centimeters cubed. All the units are in centimeters. If we wanted to convert that to capacity, we have to remember another conversion which we've talked about. We recall that we have 1,000 cubic centimeters. Sometimes people who talk about motors talk about these as cc's, cubic centimeters. That's the proper symbol. Cm with the power 3 is 1 litre. We have 45,239. If we divide that by 1,000, we'll have 45.2 litres if we round that to 1 decimal place. That's the capacity. You're ready to do some questions now.